Alright, a quick chat about enzymes. Right, enzymes, first thing we have to know, they are made out of proteins. And proteins are made out of amino acids. And my amino acids are all joined together and folded up inside the organelle called a ribosome. Right, so that's us going back to our protein synthesis. What we're looking at here, though, is how enzymes work and why they denature. So these are my keywords for this. This could be quite a long video. Right, I'm going to draw what we like a stylistic, kind of a model for what an enzyme looks at. And it looks a little bit like Pac-Man. Okay, so this is my enzyme. It's a protein, excuse me, made out of amino acids. And the important part of my enzymes is this bit here. This is the part of the enzyme that actually does its job, that does the job. This is my active site. Now, my active site is the source, is the area where enzymes actually do their job. So, every enzyme has got a particular shape, and that particular active site has got a particular shape, so it can do a particular job. So, let's just say that I had something like a carbohydrate, and I wanted to have my carbohydrate broken down. This enzyme can do that job because my active site fits with my carbohydrate. Okay, I might actually just write carbohydrate in there. Carb. So, the proper job of an enzyme is that my carbohydrate will combine with, interact with the active site, and then it will split up into two different molecules, two sugars. Alright? So, this particular enzyme might be working in the digestive system. Now, keywords that we have to remember. First off, that this is an enzyme. That this is my active site. And that this thing that my enzyme is actually acting upon is my substrate. When my enzyme interacts with my substrate and makes two new substances, these things are called my products. So, enzymes are specific. They have specific active sites that make specific substrates turn into specific products. So, for example, there's the enzyme pepsin. Pepsin is a protease, so it breaks down protein. It is found in your digestive system, and it breaks down protein into amino acids, abbreviated into AA. So this is my enzyme, pepsin. It can also be called protease. This is my substrate, protein, and this here is my product, amino acids. Now, the important thing to remember is that unless my active site is the right shape, my enzyme will not work. So if I had something like, I don't know, a fat, okay, so this is my fat, this is a lipid. I just misspelled lipid, pretend I didn't do that. This is my lipid. My lipid doesn't fit into that active site, it's the wrong shape. So if I change the shape of my active site, I change how my enzyme works. So I'm going to redraw my Pac-Man enzyme, and I'm just going to put onto here a big E, so that we can remind ourselves that that's my enzyme. So if my enzyme has got this shape, it can break down my carbohydrate substrate into simple sugar products. Okay, enzyme, my substrate, and my product. Now, if I put in something like a lipid, or a fat, or a protein, this thing here won't fit into that active site, so there will be no interaction. It won't work. It's a little bit like me trying to use this key for my door in my car. The key doesn't fit the lock, so there's no point in me trying. Now, if I have a look at a graph of how enzymes work, let's say I was to turn up the heat. Alright, so if I was to heat up this enzyme, it's a protein, so if I heat it up, it's going to change shape. So this is my original shape. Let's just pretend that I heat it up a little bit and it morphs into that. That instead of having this active site, it actually changes around a little bit and turns into a new shape. That means it's not going to work as well as when it had the perfect shape. It's like me bending my key slightly. You know those locks that you have to kind of wiggle a little bit before they work? Alright, that's what might happen. So if I heat up my my enzyme, it's not going to work as properly. So I'm going to have a look here on my axes here. What I'm going to say here is activity. So the activity of my enzyme, how fast it can do its job. It can break down 1 million molecules a second or 10 million molecules a second. And down here I'm going to have heat or temperature. If Mr. Howard is watching this, I apologize for getting them mixed up. Alright. So let's say in the perfect conditions, this is my enzyme, it can work that well. It can do this many activities per second. But if I change the heat, if I change the temperature ever so slightly, it becomes a little bit less effective. And let's just say I was to change the heat even more. If I was to heat it up even more, let's say that my body started getting a fever and I started heating up a lot, then it's going to change its shape again slightly more. At this point now, there's not even a tiny dip. It's just not going to work at all. All right. Alright, so what we get there is we get the beginnings of that normal distribution curve, alright, because it'll happen the same way up or down. Right, the word that I use for an enzyme changing its shape because of temperature is denaturing. My enzyme becomes denatured. It changes how it normally is, alright. Now, what are the things that can cause my enzyme to change its shape? Well, I've already said here temperature. If I heat it up too much, then it's going to change its shape. The other thing is pH. If I drop concentrated sulfuric acid on an egg, that egg isn't going to stay the same. It's going to change its shape. It's going to change its nature. It's going to denature. And the other thing is mutation. Because remember that my enzyme is a protein and it's made out of amino acids. So if I change the code, if I change the order of amino acids going into my ribosome, it's going to have a different shape. Okay, that's it.